Hello and welcome to our video solution to problem 2 from quiz 2. In this problem we're asked to use substitution to compute an antiderivative for, oh my goodness, what a crazy looking function. This looks very complicated. All right, well, the first wave substitution thought, right? What you should be thinking sort of is when you're going to do a substitution, the first thing I'm looking for is, can I find some function in my integrand as well as its derivative, right? So can I find a u and can I find a u prime in there somehow, some way, right? And it's okay if they're multiplied. It's okay if the u is on the bottom and the u prime is on the top, like that's fine too. We're just looking for a function and its derivative. So, well, let's see, we have a fraction, so maybe we look at something like this, right? So I'm going to look at the bottom and I'm going to find its derivative and see if it shows up. So let's just do this on the side. So if I have 5e to the x minus sine of x plus x squared minus 1 cubed, and I take the derivative. All right, I can do it term by term. A derivative of 5e to the x is 5e to the x minus derivative of sine is cosine. And then, well, I have to do a little chain rule action here. So I'm going to have 3 times x squared minus 1 squared. But then I have to multiply by the derivative of x squared minus 1, which is 2x. And if I combine these outside pieces, I'm going to get 6x times x squared minus 1 quantity squared. All right, so that's my derivative. And oh my goodness, how lucky did we get? 5e to the x minus cosine of x plus 6x times the quantity x squared minus 1 squared. So this tells us our substitution is going to be u equals 5e to the x minus sine of x plus the cube of x squared minus 1. So that du, all right, now remember I'm taking the derivative and then I'll put the dx on the other side. So du is going to be 5e to the x minus cosine of x plus 6x times the square of x squared minus 1. Okay, great, because now I can just replace this entire numerator times dx with du and the denominator with u. So this is all extra stuff. My antiderivative is now equal to du over u, right? Like that's the integrand now, it's just du over u. So that's an antiderivative will be the natural log of the absolute value of u, and then I can replace u with 5e to the x minus sine of x plus the cube of x squared minus 1. Whew! Oh man, that looked like it was going to be so difficult, but it turned out to be okay, right? We just need to look for the right things. Find that function, find its derivative. Now, there are higher level substitution problems, right, that are more complicated, and we'll get to those. But for now, like this is the first thing we're looking for with substitution. Find a function, find its derivative, and you're good to go.